All right, in this video, I'm just going to apply the power rule to certain polynomials. Actually, just get you used to applying this rule, and then I'm going to show you a problem at the end that's kind of a classic AP problem that you'd want to be comfortable with. So if we apply the power rule, these problems are very, very easy, right? We want to find the derivatives of these functions. With the power rule, it's straightforward, right? We bring down the 6, we diminish the power by 1, and that's the answer. But the second one, you'll notice there's a constant in front, and the idea here is that derivatives have what are called linear properties, which means that constants can factor out. So this is the same as 6 times the derivative. I'm kind of switching notations here, but you wouldn't write it like this, I'm sure, when you're doing the problem, but just to be technical for this first example. This is just 6, so I kind of like thought of the 6 as being a constant that can factor out. Of the process is 6 times the derivative of x to the 5th is 5x to the 4th. So it's just 30x to the 4th. At some point in your explanation of calculus, you learn that the power rule works for all types of numbers. And then if you ever take a complex variables class, you'll learn it even applies to complex numbers. So the derivative here is, we bring down that 1/3, and then you have to subtract 1 from 1/3, so just be careful, that's negative 2/3. So you can leave your answer like that, but if you were going to evaluate, you might write it as 1/3 cube roots of x squared. X to the pi, remember pi is just a constant, so this is just pi, x to the pi minus 1. We're done. This one here, let's do this one by noting. So I'm not going to be as rigorous as I was above on letter B, but again, derivatives have what are called linearity properties, which means the derivative of a sum is the sum of the derivatives. So the derivative of 5x squared is 10x, and the derivative of 2x is 2. Similar idea here, the derivative, if you just take note, we bring down the 2/3. 5 times 2/3 is 10/3. X to the negative 1/3 minus 1/2 times 4 is 2, x to the negative 1/2. So just be aware of subtracting exponents across 0 will make them negative. So let's finish with this problem. This is kind of a classic AP style problem. It's a limit, and the idea is to not do this limit as you would if you had to do an algebraic approach, right? You're not going to expand x plus h out, x plus h to the 12th out. That's just insane. I mean, you can if you're interested, but it'll take you forever. The idea is to notice this is the derivative. This expression is the derivative, right, of a function. It's f prime of x, where f of x equals, hopefully you can pick out that it's x to the 12th. So now we use our power rule to evaluate this, right? F prime of x is clearly 12x to the 11th. So this limit, were we to evaluate it out, is just going to evaluate to 12x to the 11th.